Today, I'm going to be talking about migrating 600,000 lines of code from Flow to TypeScript. So first, a little bit about me. I am Chris Griffing. Oh, actually, hold on. Let me make sure this server's running. There we go. Okay, so a little bit about me. I've been a dev for around 10 years. I just got into developer advocacy at Griffing in the past year and a half or so. And I'm really liking it. I get to make content and come out to events like this and speak. I program on Twitch in the software and game dev category. I do that like 5 days a week, which is really fun. Yep, I see another streamer out there. And I love snowboarding. It's my favorite thing to do besides streaming. They're probably tied at this point. So if you want to get any of my socials, this is the QR code. I'll be showing that later if you want to scan that, and you should be able to grab it from the recording later. So first off, what is Gitkraken? If you haven't heard of it, our main product is a desktop application. It's an Electron app, and it just makes Git easier to work with. It's really cool, actually, like the way you can visualize things using the graph and a bunch of the cool AI features we've added lately. This isn't a product pitch, but it is about how we rewrote this entire app. So I do have to at least explain what it is. So just a little bit of the product part. We do more than just this desktop view. We also have GitLens and VS Code, if you guys have used that before. Yep, I'm a big fan. I always have VS Code installed, or GitLens installed in VS Code, but I forget about it all the time. And then when I set up a new machine, oh wait, where are my annotations? Where's those like inline blame? So yeah, one of those tools that kind of flies under the radar for a bit, but incredibly useful. And we have all sorts of other stuff too. I definitely think check it out if you want. But let's dig into the history of Gitkraken. So the company is originally called Axosoft, and we have rebranded to Gitkraken based upon this product. Technically, the company is still Axosoft, but we do business as Gitkraken. And Axosoft made this thing called Glow boards, which is basically like a Kanban board, like a Trello board, or things that you might see in Jira and all that stuff. I've never actually used it myself, and this was the most recent screenshot I could grab. And it says Gitkraken in some places on here. No, this is actually an older one. So yeah, it's actually hard to find something on the internet from 10 years ago. It's crazy. So it was born out of an internal hackathon we did as Axosoft. And I think that's really cool. Like, more companies should do these internal hackathons, building products and just letting your devs be creative. It's really fun. So yes, we built this because our team was having issues using Git, and we decided to just build something. And back then, Electron was still pretty new, right? Atom still existed, and we were using React, and it was cool. But we wrote it with just regular JavaScript. So instead, by 2017, we needed to choose a type system, right? The application was growing very big, and if you don't have a type system, some really easy bugs can crop up in your apps. So, right, like why? I just explained a little bit, but it's a better developer experience. You get feedback at dev time instead of just runtime. And that means that you can catch bugs earlier, so you're giving your users a better experience as well. Type systems just really help us be more productive. And at the time, there were basically like 3 big ways to do a type system on top of JavaScript. There was Flow, made by Facebook. There's TypeScript, which I think most of us are probably familiar with at this point. And then there's a thing called Reason, which is basically a flavor of OCaml, and it had very strong type safety. It was used in the Facebook Messenger app, at least at one point. And it's really cool, but Reason, you have to write like a totally different language. The interop with JavaScript is a little tougher, and you have to like write all of your types because no one makes Reason types that they ship with third-party libraries. So let's dig into what Flow is. It was made by Facebook and open sourced in 2014. And it's still used in React today. Even though Facebook ships types now that are TypeScript types, they're still using React internally. And they're probably using it in all sorts of other parts of their code base too. But pretty useful. And it was popular enough at the time, like because we were using React, we decided let's use what Facebook uses. So we had picked Flow at the time. And here's a quick syntax example. It's a little small. It basically looks a lot like TypeScript. So the only difference we can really see between TypeScript and Flow in this case is the position of the optional like question mark for a property that doesn't have to be there. Here in Flow, it goes right before the type instead of on the property. Pretty simple, but there's other differences too, especially when you start looking in like how they do their type checking. So in this myfunc function, we're doing a check for if foo.bar. And then we do a console.log, and then we do the return of foo.bar, but Flow doesn't actually know that foo.bar is still there anymore because it is very strict about where side effects can come from. And if you're unfamiliar with functional programming and side effects, it just means that this technically console.log is creating a side effect by printing something to your dev tools, right? So it doesn't know that. It doesn't know that console.log is a safe side effect. It could actually be modifying state all over the place. And if you wanted to hack on it, right, it's just JavaScript. You can hack on console.log and alias things and do all sorts of fun stuff. It may actually cause side effects that you don't even know about. So when we really want to like compare these things and understand how the migration worked and what the syntax differences are, let's look at a couple snippets of code between Flow and TypeScript. And let's like think about how they are different. So Flow is a Babel plugin. So Babel is the compiler, and then it's just a plugin for that with a parser and all that stuff, whereas TypeScript ships its own compiler. Right now, TypeScript's compiler is written in TypeScript, which is weird, right? Bootstrapping and all. But eventually, they're going to change it to Go just so that we can get faster compilation times. But because they own the compiler, they can make decisions like that, whereas Flow is just stuck with whatever Babel does, basically. Another big difference between them is how they do type inference. So Flow is much stronger at inferring the types without you having to explicitly state these things, whereas TypeScript generally prefers that you annotate things so that it can figure stuff out a little quicker. And this kind of gets into why we had to migrate, because Flow is so strong at inferring these types, it's doing a lot of checks at dev time that can slow you down. Another big part, nominal versus structural typing. In this case, nominal just means by name, if you haven't heard that term before. Both are mostly structural, and that just means that they're going to look at the props and the names of things and assume that those types might be the same thing, or at least like let you use them in a similar way. But Flow will not let you do that with classes. So all classes are strictly by the name of the class. Doesn't matter if they have the same props, like this snippet that I have here, right? We see class foo with name string, and then class bar with name string. In TypeScript, right, we have this function called sayName, and we pass in a bar to it. That's totally fine. In Flow, this would be an error. So definitely some subtle differences in how you use these things. And then strict structural typing. So in general, in Flow, you are not allowed to add extra props. So in this example, we have our type user. We have a function called print user that takes in user and then :user. And then from there, we just like print out a user1, which is using this like user type. Then we have const user2, which is an ad hoc object that has the same structural shape as user1, but we add this extra prop. In Flow, that print user with user2 is an error. So some of these subtle differences between these means that it's not just straightforward switching between Flow and TypeScript, because they're going to complain about different things at compilation time. And then finally, just to reiterate where the question mark goes for optional properties, it can definitely be a little confusing at first, but it's not something that you would want to go through 600,000 lines of code and change individually. So we're going to get into how we did that here in a second. So first off, why did we migrate? Well, like I said, popularity is a big part of it, but speed of our developers was a big part too. This is not necessarily the best graph. This is just using Google search trends, and we can see that TypeScript is actually really easy to search for. Flow, not necessarily. You have to add that JS to it. And over time, Flow has not gotten much popular as far as search trends go, but maybe I picked the wrong keys to make this graph. But this actually shows us a lot more. So we can see that Babel preset Flow, the library that you would download to actually compile Flow, is that blue line, and then TypeScript is the orange line. Nowadays, it's obvious, just use TypeScript. But back then, back in 2017, those lines were much closer together, so it wasn't as obvious. So we can be forgiven for making a decision at the time that wasn't quite the best one. And then here's another big part, type availability. So when you're using third-party libraries, do you want to write all of your custom types for those things? You're going to have to look at how they're used, where it's happening. Instead, you can use this centralized type repository called definitely typed for TypeScript. You used to have to get your React types from definitely typed. Now that they ship that with the library, it's so much nicer. But flow typed also exists for flow packages, When we look at the repos on GitHub, there's 8,600 packages supported for TypeScript, but only around 1,000 for Flow. And if we start thinking about that, these are just the ones that are in the central repository. If we look at the package-specific ones where they might ship their own types, I did this search on GitHub. It's not very scientific, but it's easy to find the TypeScript ones because they define types, and then whatever inside of their package JSON. For the Flow, it's a lot harder because there isn't a place to do that in the package.json. So you have to look for maybe this like module.js.flow file that'll have all the types. And Flow will generally look for that in your third-party dependencies, but these aren't necessarily going to be on a GitHub repo because it's a build artifact instead of something that you like commit. So it's not a great search, but it does at least kind of like give you a little perspective. 1.1 million results for the package JSON stuff, and then 800 results for module.js.flow. Not very popular right now. So another big reason we wanted to migrate is because we were having performance problems with an older version of Flow. And it's something that they may have fixed in recent versions of Flow, but when we tried to upgrade, things broke because they were changing enough things over time that some types would work in an old version of Flow, but they wouldn't work in a new version of Flow. Or just how we were structuring our application, it would have been just as much effort to upgrade Flow as it would have been to switch to TypeScript. So when you think about it, though, we all know TypeScript. Can I see some hands of who hasn't used TypeScript? Or who has? That's more fun. Everyone. All right, perfect. So yeah, we can hire someone who knows TypeScript and they can be productive within one day. Whereas Flow, there's all these little idiosyncrasies that are different that you'd have to train someone up, and there's going to be some growing pains of getting them into the org and teaching them how to use the code. So now, right, the why, that's fun, but how is way more fun. So we ended up having one really dedicated dev, John Alden, awesome senior dev here at GitKraken, and he just took it on himself to see if he could do it. So he had a fork or a branch of GitKraken Desktop that he was constantly pulling from main because we're always shipping new code, and he was just seeing how close we could get in an automated fashion. So we probably wouldn't have been able to do this nearly as quickly without his effort. Very good dude. But the how of it is he used this thing called a code mod from Stripe. So Stripe actually migrated millions of lines of code. And I'll get into what a code mod is here in a second. But yes, we were basically following in the footsteps of someone who did way more work in this space. And it just, it was nice for us to follow in that path without having to forge it ourselves. So yes, they migrated millions of lines of code, crazy. And there's a quote that is from Mike Fix, engineer at Stripe. Seriously unreal. I remember a short time ago laughing at the idea of TypeScript ever landing at Stripe, and then I woke up Monday morning and it was here. And he crosses out Christmas because it's like it was a Christmas present, right? Being able to just have TypeScript in your code base like that, and devs could just be more productive and move. So let's dig into what a code mod actually is. A code mod is a way of using the abstract syntax tree. And the abstract syntax tree is basically these nodes that make up your code. So if you have a statement sequence, like a function, it might have a while loop inside of it and a return value. That while loop is then made up of the condition and the body. And the condition has these compare, op, and the operation that you're doing between these things. And these are all just nodes, objects, that make up your code base. This is what your compiler sees. This is what the parsers see. So this is one of those things that is hugely powerful. When you start learning about abstract syntax trees, you start seeing them everywhere. TypeScript's using one. You can get access to the TypeScript abstract syntax trees just by using the compiler in your code. So you can start making your own code mods. It's pretty easy, actually. But yes, very interesting to just see this pattern of this tree of nodes. And the code mod goes through and modifies them. So what we can see is that this flow to TypeScript code mod has three major commands or functions. There's setup to install TypeScript and set up type declarations for some things and stuff like that. And then the big work happens with convert, which is using Babel to convert your files from Flow to TypeScript. Because again, Babel's a compiler, it's a parser, and it has access to the abstract syntax tree for you. And you need Flow to understand Flow. Right? So you can't break down an abstract syntax tree of Flow using the TypeScript compiler. It's a totally different syntax. So it uses Babel first, and then modifies that into TypeScript. And then finally, there's this fix where, yes, that first step isn't going to be perfect, and the fix goes through and uses the TypeScript compiler to then respond and deal with the errors that are going to happen inevitably. So was it perfect? Did it work first try? No. Nope, definitely not. So what went wrong? Well, we were using third-party libraries, and like we saw, not many third-party libraries shipped flow types. So instead, we had to write our own. And it turns out that the custom types we wrote weren't one-to-one with what they were shipping in TypeScript. So when we tried to compile, it would error out and tell us that, oh yeah, this type doesn't match what the library is actually giving. And at that point, like, yes, the third-party custom types was a fix we had to do, but also, like, how many people can just stop working and work on tech debt, right? Like, no, you have features to ship, you have bugs to fix. So luckily, we do have the idea of tech debt sprints that happen, I believe, like near the end of the year-ish, just to make sure that we are solving problems, and also, like, people are going on vacation anyway, so you're not going to get that much done during November and December. But yes, during this tech debt sprint, it came up like, hey, we'd love to switch to TypeScript. And, you know, our director of engineering asked, how long is it going to take? And our ambitious dev, John Alden, said, oh, a couple days. At which point she squinted, and you know, our director of engineering did not believe him. Said, how about a week? And okay, he gave it a shot. He tried it within a week. And within that week, boom, he had it done and working. So it was similar to that Christmas idea from the Stripe stuff. So now let's look at the results of what we did. So number one, faster build times. I had to go through our builds on GitHub Actions. And I went back and looked at how long these things were taking like a year and a half ago, 2 years ago. And they were like 40 minutes long. That's not great. If you only have one runner, you're going to have one like PR push, and then someone's waiting 40 minutes for that to finish. And then the next person who maybe pushes code 5 minutes after you has to wait 45 minutes or whatever, right? Like you're compounding all of this as this chain of like builds that need to happen. So number one, you could just add more like agents and stuff, but that's just throwing money at the problem, when instead you can optimize things better. And TypeScript was able to compile in basically half the time, which is a huge win for us. It's a better developer experience. We were getting faster in-editor feedback. So our devs, right, when you're maybe writing some code and you're checking for, or you're using a property on an object, and then all of a sudden TypeScript tells you that object could be undefined. That was taking like 30 seconds in Flow, right? You'd write your code and you could get up and like grab a coffee or something, and then come back and finally have the type told to you. Instead, with TypeScript, you get that within seconds. And like with a 600,000 line code base, that's really impressive actually, because TypeScript focuses on the file first and then spiders out, whereas Flow looks at the entire code base. So it kind of makes sense. Next, fewer custom types, right? Like all these libraries ship types for us now. So we could like delete code, and that's the best thing ever, right? I love deleting code. It's my favorite part of programming. And faster dev onboarding, right? We've been hiring because we're growing and we have more features we want to ship, like all this AI stuff. We have devs that are able to just be productive within a day, just hammering out code, being productive, making stuff happen. So that's about what I got right now. It looks like I got about 6 minutes, so I could take some questions if we want. There's my slides if you want to, or not my slides, there's my socials, and I can post my slides wherever. I guess the Discord is probably the right place. Okay. So yeah, any questions? Yeah. I think some of the stricter inference, right? Just being able to know what a type is without having to tell it is pretty nice. So it's just less code to write, really. Anyone else? Yeah. I think so, yes. Well, so technically GitKraken desktop is it's a binary. So we're not like deploying out to a server. It's just a, just a build that happens and we get the artifacts. Yeah. Ooh, my favorite feature of GitLens? I mean, that inline blame, it's just like so useful. Like you can hover it and get like all of the info about the commit. I really like that part. The commit graph is really nice. Like if you open the commit graph, you see this like timeline. And I like merging instead of rebasing. So you get this like Zen garden of like branches merging. It's really nice. Yep. Okay. Awesome. Yeah. Yeah, I mean, we're working a lot on our AI stuff. We just published an MCP server that uses a lot of our like services, so you can have all your integrations with Jira and GitHub and all that, and you can query using Cursor or whatever and use these tools from our MCP server. And we just launched that within GitLens, I think, within the past week. So you don't even have to like do anything with GitLens. If you're on a new enough version of VS Code, it'll install for you, and you can just start using it. Anyone else? Yes. Oh, thank you. I appreciate that. All right. Oh, yeah. I haven't yet. Have you? Oh, so that might be good. Yeah, we'll have to check that. Yeah. All right. Yeah, I'll see. I bet John Alden's probably got some branch. All right. Anything else? I just want to make sure I don't leave anyone out. Yeah. So again, because GitKraken Desktop is just a binary that you ship, there's less there, but we do have this like build server that when that goes down, like it was very flaky for a little while. So we improved our build server as well, and that helped. Just building for like different platforms and OSs. Yes. Effect. Effect is tough because once you start using it, it kind of like pollutes the entire code base. You got to use it all the way down. So we haven't necessarily done that at all. And with 600,000 lines, that would be tough. But it is very compelling. Like it's a cool library. I think it would make the most sense even if we started using it in some of our backend services, like microservices and stuff. All right. I think that wraps it up. Cool. Thank you so much.